So compound interest. We're going to go into some applications of exponentials. And here we're going to look at an example of $100 with an 8% interest over 2 years. So there are different ways that we can compound this. Compounding means is how often do we add the interest to the total. So we're over on this left column, we're going to look at the number of compounds. So if we do it yearly, this is just an explanation of where the compound interest formula comes from. So let's pretend that we have our 2 years here. Now every year we're going to take 8% and add it to the total. So to actually figure that out right away, we multiply by 1 plus 0.08. And this is what you saw earlier when we did 1 plus or minus r. Here it would be 1.08 times 1.08. So my formula, I would write 100 times 1.08 twice, because it's 2 years. So they had this idea to make more money. You can compound more often. So if we do this semi-annually, will still be 2 years. But we're going to split those years up into 2, and we're still going to do 1.08 over 1 year, but we're going to kind of cheat by doing 1.04 twice. So what we do is we split our interest in half, and then we do twice as many compounds. So that would be 100 times 1 plus, and so we're going to first take our interest divided by 2, but then we're going to do twice the number of years. So if I go to my calculator, the first amount I get here is 116.64. So I get $6.64, or $16.64 in interest. Now, if I put the other one in my calculator, I get slightly more, 116.99. So you might ask, well, why stop at semi-annually? Why not do it quarterly? So it's still going to be the same amount of time, but we're going to chop up our years into fourths. And for every one of these fourths, we're going to actually take our interest and divide it by 4. So each one of these is going to be 1.02. So the formula would be 100 times 1 plus 0.08 divided by 4, and we're going to do it 4 times as often over the 2 years. So if we end up doing that, I'm going to end up with $117.17. So instead of gaining 30 cents, we gained closer to 20 cents. And so you could keep doing this. We could do this like monthly. I won't draw the picture again, but it'd be 100 times 1 plus 0.08 divided by 12, because there's 12 months, and we do it 12 times as often. So it's really going to be to the 24th power. And here we're getting 117.29. So we got about 12 cents there. So you can keep doing this. You could even do this daily if you want. But most banks stop at daily, because you'll see that there's a decrease in how much you get every time you increase your compounding rate. So most banks stop at daily because that is where you start to actually spend more time computing than actually getting money. So daily, you would do the same thing. You just divide by 365 and raise to the 365 times 2 power. So if you compound k times, this is the formula. Principal times 1 plus the rate divided by the compounds to the power of k times t. So hopefully that makes more sense, and also the book calls this A for the total amount. So you might be asked a few questions, like, for example, if we invest $3,000 at 6% compounded daily. Oh, sorry, monthly. Then you could ask two questions, like A, basically, how much after 5 years? So let's plug it into our formula. 3,000 times 1 plus 0.06 divided by 12. 12 times 5. Now, be sure you're checking how you put this in your scientific calculator, because some people get extraordinarily large numbers because they're forgetting to do parentheses here, and they're also forgetting in their calculator put parentheses there, and even here. So you should be getting $4,046.55. If they ask how much is interest, well, $1,046.55. The question might also be, when will it double? The question is, when will this equal 6,000? So here's how I'd work through it. First of all, I would divide by 3,000. No, that's just going to be 2. And oftentimes, the book doesn't even give you a starting amount. So you could just set it equal to 2, or you could just pick whatever amount you want to start with. I am then doing this in my calculator. 1.005 to the 12t equals 2. Now we know how to solve this because this is an exponential. So I'm just going to do the translation of log base 1.005 of 2 equals 12t. So t will be, if you divide by 12 and also change a base, t will be that. So let me do that in my calculator. What I see here is that after about 11.6 years, or about 12 years, our amount is actually going to double. So again, if they don't give you a starting amount, it's okay. Just choose any starting amount. Just make sure you equal it to twice the value.